everything that we have learned. Kita akan buat summary dulu. And after the summary, maybe kita akan masuk more on solving heat equation, okay? So any question so far nak tanya saya? Berkenaan dengan kelas yang you dah pelajari sampai sekarang, ada apa-apa nak tanya? Boleh kita mulakan? Thumbs up ke? Down ke? Okay, Syazah kata okay, boleh kita proceed Okay, kelas. I hope you are still there sebab kita baru minggu ke-10. Ada 4 minggu lagi, okay? Hang in there with me. Okay, don't feel discouraged. Perjuangan belum tamat lagi, masih ada lagi, okay? So, let's look into my whiteboard. Okay, everybody can see my whiteboard, right? Okay, so kita dah belajar. So the main thing about this PDE, what is the main thing about the PDE? Solving the types, kan? Kita ada types. Okay, there are 3 main types. We have parabolic. When you call type, dia memang jenis parabolic where you can get by b squared minus 4ac equals to 0. And then you have hyperbolic where you obtain by looking at the equation b squared minus 4ac greater than 0. And then you have elliptic, b squared minus 4ac less than 0, okay? So, if it's a first order, ada yang kata first order tak ada type. Okay? AUX plus BUY plus CU equals to 0. Not 0 equals to 0 lah, equals to kalau dia homogeneous, maybe F. Okay? So, if F is equals to 0, kita ada homogeneous. Okay? And this is the first order. So, first order boleh ada type. Okay, masukkan je lah. Masukkan saja pada equation yang ada. And if it's a second order, you have AUXX plus BUX5 plus CUYY plus DU. Betul ke? AUXX plus BUX plus CUYY plus DUX plus EUY plus FU equals to G. Okay, misalnya macam ni lah. Okay, and then this is the second order. So, if again same thing, if G is equals to 0, you have homogeneous equation. So, these are the types that you can find out from PDE. Now, kita dah masuk kepada, we learn some basics. How to solve using first order kita dah cover. Kita dah cover macam mana nak solve. Okay, you can use characteristic method and you can use, what do you call it? Coordinate. Okay, coordinate method. But some of them you can also use separable variable. Kalau dia jenis yang easy to solve, no? For second order PDE, this is my second order. Okay, for second order, you can solve using, of course, you dah study pasal canonical form untuk parabolic, hyperbolic, elliptic. Kita dah cover kan? But canonical form ni kadang-kadang you cannot get exactly the equation of U. Okay, kadang-kadang you kena stop at certain, dia kena reduce daripada complicated equation, dia akan reduce kepada more simplest form. Okay, now we are interested in look at second order again for that 3 types. Elliptic, parabolic dengan hyperbolic. Now, we know, we have learned about some other method like such as Fourier. series and Fourier transform. In between kita ada Fourier integral. Okay. Why we study this? What are the connection between these and the solving the PDE? Ada connection dia. We can see that Fourier series ni nanti you will use especially the half range series to solve heat equation. Siapa yang dah tengok video saya berkenaan heat equation tu, memang kita ada gunakan. So kita tak payah kira, kita ambil je solution dia for half range series, okay? And then for Fourier transform, okay, when you use Fourier transform, when you use Fourier series, and when you use Fourier integral. Okay, and there's another one actually, Laplace. Laplace transform. Okay, semua ni kena tahu bila gunakan, bila kita tak guna and so on. Okay, so Fourier series ni biasanya kalau kita nak dapatkan specific interval, okay, kita ada macam periodic 2 pi interval, and you can have arbitrary interval. Okay, tapi dia finite lah kan, dia finite finite interval. Maksudnya dia adalah di if you're given x or t, dia adalah let's say from minus L to L ataupun minus P to P. Okay, Fourier transform ni bila dia infinite interval, x saya from minus infinity to infinity. Okay, that's why we need to know, that's why we need to learn. And usually Laplace transform dengan Fourier integral ni, dia adalah lebih kepada semi-infinite. Semi-infinite. So let's say from 0 to infinity ataupun from minus infinity to 0. Okay, so if you gotta be careful with what are the condition given dalam soalan tu, you kena tahu apa yang you perlu gunakan. Okay, any question so far? Ada nak tanya? Semua jelas ke apa yang saya cuba sampaikan ni? Okay, good. So now last week kita dah tengok how to solve parabolic equation. Now the example of parabolic equation is the heat equation. Maybe saya boleh terangkan sikit what is the heat equation. So the heat equation is second order. Second order is given by ut equals to alpha squared uxx. This is my heat equation. Ini yang kita nak tengok how to solve this. So you have a rod. Dia boleh rectangle, tapi kita hanya untuk for degree we just looking at this rod lah. Okay. So kita akan assume that there is no energy loss throughout the side of the rod. The rod boleh insulated. Okay? Or dia boleh ada dua benda. So the rod is insulated. Maksudnya ada penebat ataupun the rod is at rest. Okay, so what you want to do is kita nak solve different types of condition based on initial condition yang kita dapat lah. Okay, so to derive this ada dalam buku saya muka surat I think page 114. Okay, page 114 until 117 you can look into the derivation of the heat equation. Okay, I don't want to look at the derivation right now. Okay, I just want to ask you some question because it's involving the rod. We need to be careful. Apa akan berlaku pada hujung rod ni, okay? So kita boleh tanya soalan like how can the temperature change in terms of time? Kalau both end constant tapi different temperature, what will happen? Kalau kita ada insulation, penebat, what happened, okay? All this can be known based on the boundary condition. Okay, boundary condition. So there are few types of boundary condition. There is, we call it Newman boundary condition. And then there is Dirichlet boundary condition. There is also Robin boundary condition, mixed boundary condition and periodic. Okay, kita takkan tengok boundary dengan periodic. We will only look at these two. Okay, what are the difference between all these two boundary condition? Okay, let's look at Newman. So Newman boundary condition, this is general and this is also for hyperbolic nanti. Okay, Newman boundary condition is kita ada rod, we have given a rod. So what happen is at the end ada insulation. Okay, kita ada penebat. Let's say kita panaskan di sini. Okay, kita panaskan di sini. And then we are looking at how the heat transfer. So bila dia kata there is insulation involved dalam soalan you. Soalan takkan kata this is Newman boundary condition. Soalan akan kata there is insulation at the end of the rod misalnya. That mean maksud dia adalah kita kena tulis dia macam ni, ada derivatif. Okay, meaning kalau you nampak je derivatif macam ni, okay, there are two types of question. One question will just give you in the terms of paragraph. Kita kena come up with equation. Okay, tapi ada equation yang memang dah bagi equation dia. Kalau you nampak ada derivatif macam ni, there is a derivative in your equation, meaning is a new, meaning ada insulation involved. Okay, now kalau kita ada rod di mana heat dia constant. Okay, we have constant heat sampai end of the rod, constant heat. And kita panggil dia Dirichlet boundary condition. Okay, contoh dia kita ada something like this. U0 T equals to U1, ULT equals to U2. Tengok, tak ada derivatif langsung kan? Tak ada partial U over partial X or partial U over, okay? This should be equation saya kena betulkan Kalau dia melibatkan T, kita kena differentiate respect to T, not X. So this is partial T, partial T. Okay. Let me just, give me 2 seconds. No, I was correct. Equation tadi correct. Memang X sebab kita ada X and T. X is the initial condition and T will be normally referring to my boundary condition. So betul lah yang ni. Okay, so we have two constant, U1 and U2 So kalau nampak macam ni, kita tahu dia tak ada insulation involved. So heat flow dia constant lah. Now, kalau kita katakan Robin condition, Robin ni, Robin boundary condition ni biasanya when there is a heat loss. Kalau misalnya soalan tu kata heat is lost, okay? That means equation dia kena ada negative, something like a constant here, partial U over partial X, LT equals to some equation function. Okay, usually equation tu dia kena bagi. Tapi yang penting dia ada negative here. Okay, dia ada the one with the L, dua-dua belah kita punya rod, kita ada this is where 0 sampai L kan, panjang dia. So This is from L, then this is for my 0, T. Contoh ni contoh. Okay, minus U1 lah. Okay, so these are the types of boundary condition. And obviously, you boleh ada satu yang constant, satu yang insulated. Okay, macam tadi ni, dua-dua belah insulated. Two ways. Dua-dua insulated. That's why you have two derivative here from 0. The length is from 0 to L, kan? But you can also have where one is insulated and one is not. Then we will have a mixed boundary condition. Okay, mixed boundary condition ni pula, dia contoh dia macam ni. U0 T equals to U1. Okay, and then lagi yang paling hujung sekali, dia ada penebat. So insulation happen here. Okay, so there are some problems that can be referred to this boundary condition. Kalau Dirichlet ni, kalau senang nak ingat, Dirichlet ni contoh dia, you can say stretch of a vibration string. Okay, stretch of a vibration string, kita boleh katakan dia adalah Dirichlet boundary condition. Ataupun kita boleh kata, kalau dia kata stretch of a vibration string ni, dia lebih kepada wave kan? Sebab dia melibatkan string. Kalau heat yang melibatkan Dirichlet adalah heat conducting rod with two ends in a heat bath. Okay, so kita letak satu, kita ada mungkin air panas ke macam ni, kita letak kita punya rod di dua-dua belah. Okay, something like that lah. Okay, Newman ni normally electrostatic field, tapi I don't have much knowledge about it because this is involving more on engineering part, but you can just read for the Newman boundary condition. But all you can say that Newman boundary condition, if there is a insulation involved, ada penebat, then kita boleh kata that's a Newman boundary condition. Okay, any questions so far? Saya seorang je bercakap kan? Ada nak tanya? Syazri? Zulhaikal ada? Ada soalan tak nak tanya? Faham ke apa yang saya tengah explain ni?
Kita cuma tengah ni, tengah tengok.
Tengah tengok. Okay. Okay, Zulaikha, good. Okay, biasanya student lelaki yang suka tanya bila berkenaan dengan PDE ni. Tapi kelas ni macam senyap je kan yang lelaki. Jadi, saya tak tahulah. Okay, siapa lagi lelaki yang ada di sini? Siapa je? Khairuz. Apa? Siapa nama dia? Khairuz Wan? Ya. Is he okay? Shazri kenalkan? Hafiz kenalkan? Dia okay? Not sure why he's not here today. Nanti boleh sampaikan pesanan saya. Okay, now this is a summary of what we have. Suppose you dah tengok video, you dah tahu. Now, balik kepada heat equation kan. Kita nak solve heat equation. Dan if you have watched my video on heat equation ni, heat equation memang equation dia macam ni UT equals to alpha squared UXX. This is my heat equation. Okay. So there are two types of boundary condition. Tadi, no, how do you say? Not two types of boundary condition. There are few types of problems. Involving boundary conditions such as Newman, Dirichlet. Okay. Tapi boundary condition ni juga dia boleh ada something called zero boundary condition and non-zero boundary condition. Okay, saya cuba bagi example for kita tengok side by side. What do you call by zero boundary condition and non-zero boundary condition. Okay, zero ni contoh dia macam ni. Okay, ut equals to alpha squared uxx. Now, x dia interval from 0 to L. T lebih besar kosong. Okay, kelas tengok interval dia. 0 to L. Bermakna kita akan menggunakan Fourier series sebab dia finite interval. Okay? Finite interval kan? So kita akan guna Fourier series nanti. And then tengok kenapa dia kata zero boundary condition. Okay, contoh dia macam ni. U0t equals to 0. U1 saya 0. ULT equals to 0 for t equals to 0. So this is my boundary condition. Okay, boundary condition ni pada x saya. Bila x kosong, dia kosong. Pada x saya L, dia adalah kosong juga. So this is called zero boundary condition. And then you have initial condition. Ux0 equals to fx. Okay, what is my u here? Okay, uxt ni kita nak cari. We want to find uxt, which is the temperature at the position of x and t. Okay? So, alpha ni constant Alpha ni boleh constant, boleh apa saja nilai. L is the length of the rod. F ni any function lah. Okay, now what do you say about non-zero boundary condition? Okay, so equation, heat equation, kita masih merujuk kepada heat equation, something like that. Okay, now dia masih lagi kepada finite interval such that 0 to L. Okay, and then kita ada something like this. U0t equals to U1. ULT equals to U2. Tengok. U1, U2 ni, ini contoh lah U1, U2. Tapi mungkin you boleh dapat something like this. Okay, instead of U1, U2, kita boleh dapat soalan macam ni. Okay, ni 0. Yang ni 100. What that mean? Okay, contoh saya bagi kalau dia 0 dengan 100 saya boleh kata, okay, let's say there is a rod. Okay, ni kita punya rod. Okay. Pada sebelah sini, okay, pada sebelah sini kita dia berada di temperature sejuk. It's a frozen. Sejuk. So dia adalah 0 degree. Okay, so kita ada temperature, what happened here? Okay, so this rod ni kita dah panaskan dia. Okay, there is a heat happening in this rod. And then pada satu hujung ni kita bagi dia sejuk. Kita letak ais ke, tak tahulah. Tapi pastikan temperature dia 0. And the other one is kept constant at 100. Kita bagi dia, kita letak dia supaya temperature dia 100. Let's say So bila you dapat something like that explanation, so yang akan berubah ni, yang ni merujuk kepada interval yang x kosong kan? This is x equals to 0. And then this ujung ni pula depends on my x equals to L. Okay, tapi kita kata dia kept at 100 degree. So dia akan jadi 100 lah. So look at the interval now. 0 dengan 100. The boundary condition is now non-zero. Instead of 0 here and 0 here. We call it zero boundary condition, non-zero. Salah satu. Kalau dia bukan 0, kita panggil dia non-zero boundary condition. Okay. So when this happens, then you have to consider how to solve this non-zero boundary condition. Dia ada something called, okay, semua jelas pasal zero dengan non-zero boundary condition. Ada nak tanya tak? Okay, kalau okay, saya nak continue lah. Okay, to solve this, both of these, dua-dua ni, kita akan solve menggunakan separable variable. Okay, separable variable. I have given on my video how to use separable variable. Tapi for the zero boundary condition ni, dia ada for the non-zero boundary condition ni, dia ada something called steady state solution yang you kena ambil kira. Sebab boundary condition dia bukan zero. Okay, so there's some transformation that you need to do. Okay, steady state solution ni happen kalau UT sama dengan kosong. Okay, so kita akan tukar kita punya non-zero ni kepada zero boundary condition. Melalui cara steady state ni, baru you boleh solve. Okay. So, I don't know whether you rasa macam mana? Perlu ke saya bagi contoh yang sama dalam video yang kita buat untuk separable variable ni? What do you think?
Perlu doktor, perlu.
Perlu Okay, kalau perlu kita buat. Okay, now we're gonna solve this. Zero boundary condition. Okay, we're gonna solve this equation yang atas ni So saya tulis balik lah. So ut equals to alpha squared uxx x from 0 to L, u0 t equals to 0 and ult equals to 0, ux0 equals to fx. Okay, now saya dah terangkan dah what is zero boundary condition. And if you look at here, apa jenis boundary condition yang you tengok sekarang ni? Adakah dia Newman? Adakah dia Dirichlet? Adakah dia Robin? Who can tell me? Jenis apa? Dirichlet. Very good. This is Dirichlet. Okay, sebab dia tak ada partial derivative mana-mana kan? So what Dirichlet boundary condition tell you? It tells you that there is a heat constant. Constant lah, heat dia zero saja. Okay, so heat is constant. Itu yang kita boleh tahu. Heat is a constant. Okay, now to solve this, saya kata we are going to use separable variable. Okay, so to start with, kita akan kata let uxt equals to a big X and big T. Okay, big X and big T. Now, kita akan, kalau tengok soalan saya, ut equals to alpha squared uxx kan? So, kita akan differentiate respect to T dulu. Okay, so differentiate respect to T. X constant, T akan jadi prime. Okay, and then kalau saya differentiate respect to X, ux. X prime T. Differentiate lagi sekali. X double prime T. Okay, I hope you are with me. Okay, so bila kita differentiate respect to X, X yang akan differentiate lah. T akan jadi constant. Kalau respect to T tadi, X constant, T yang akan derivative. Okay, now saya masukkan pada equation saya. Ut equals to alpha squared uxx. Okay, what is ut? Ni. Xt prime. Xt prime equals to alpha squared uxx. X double prime T. Okay, kenapa dia kata separable variable? We can separate the variable, of course. Look at it. How we can separate the variable. So, saya boleh bawa T prime over termasuk alpha ni, alpha squared T di belah kiri. Di belah kanan pula saya ada X double prime over X. Okay, so don't get confused when you see the equation like this. Okay, dia sama macam ni lah, okay? Partial U over partial T sebenarnya. Okay, so don't get confused with the T prime dengan X prime and so on Okay, now what happened here? Kita dah separate variable kan? Okay. Something like dalam test pun dia ada something called auxiliary equation. Dalam test ada macam kita panggil dia apa? auxiliary equation di mana kita akan equate dia. Okay, something like partial, saya dah lupa dah. Partial x over x equals to partial y over y equals to partial u over x. Contoh not necessarily the same thing. So something like this, we need to have something for this equation to be whole. Kita kena introduce one constant. Saya nak panggil dia k. Okay, so something like this. T prime over alpha squared t equals to x double prime over x equals to k. Ni constant yang saya introduce. This k is called the separation constant. Okay, separation constant. We need the separation constant baru kita boleh equate sekarang equation. Kalau macam dalam test tu, you kata, okay, 1 is equals to this one. Or this one is equals to that one kan? Ni sama juga. Okay, now I can say t prime over alpha squared t equals to k and x double prime over x equals to k. Okay, saya boleh simplify lagi. Okay, saya nak tulis, bawa k di belah kiri. We will have, darab dengan alpha squared t kan? Okay, let's do that first. T prime equals to alpha squared kt. Saya bawa darab dia ke belah and then tolak. T prime tolak alpha squared kt equals to 0. Okay, this is first equation. Now on this part here, similarly, saya akan bawa x ke sini. Saya dapat x double prime equals to kx. Now bawa ke belah kiri, x double prime minus kx equals to 0. This is equation number 2. Okay, what you can see here, the equation 1 and 2, you have 2 ODE. This is my first order. And this is my second order. Daripada PDE, kita mudahkan dia sampai dapat 2 ODE ni. Okay, to solve the first, kita kena solve one by one lah. Okay, solve for one first. Solve for one. Okay, equation pertama ni. Okay, you can use separable variable. Ataupun you boleh guna integrating factor. Doesn't matter. Okay, let's solve that first. Okay, t prime minus alpha squared kt equals to 0. So, nak separate variable dia lagi senang kalau kita buat macam ni kan. T prime equals to alpha squared kt. And then, bawa t ke belah sini. T prime over t equals to alpha squared k. Now, integrate. This will give me ln t equals to, now I am differentiating respect to t, betul tak? Kat sini tak ada t. Kalau constant, kalau kita integrate dapat apa? T plus c misalnya. Okay, but I don't want to put that constant right now. Kenapa? Nanti saya explain. Kenapa saya tak letak constant Memang akan ada constant. Okay. Okay, tak apalah kita letak. Kita letak je. Tak nak bagi you all confused banyak. Okay, let's put a constant C1 here. Okay. Now, okay tak so far integration ni? Thumbs up kalau semua rasa okay. Okay, good. Now, what you do? Obviously, you're going to take exponent left, exponent right. So, exponent ln will give you t equals to, okay, now exponent ni saya dah pernah tunjuk banyak kali property of exponent. Exponent A tambah B, kita boleh tulis dia sebagai exponent A, exponent B. Betul tak? So this one, I can write it as exponent alpha squared, oops, I don't want a red marker, I want a blue marker. I can write it as exponent alpha squared kt exponent C1. Okay, exponent C1 ni tak payah tinggalkan dalam bentuk exponent C1 because it's a constant. So I can write it at A exponent alpha squared KT. Okay, so this is my equation yang ketiga saya dah dapat daripada involving time Okay, now alpha, what happened here? My A is a constant. Okay, now one thing we need to look at here, okay, saya sebenarnya kena introduce 3 types of K tadi. Okay, K is a separation constant. But we need to make modification for this constant. Okay, we need to choose. Dia ada 3 perkara yang kita nak choose. One is K less than 0, K equals to 0, and K greater than 0. Okay, so to do that, kita akan introduce something called lambda. Lambda squared. Okay, lambda squared Lambda squared yang kita panggil dia actually eigenvalue. Okay, now why this is important? Okay, dia ada 3 test yang you kena buat, but to save time, saya akan kata you just have to take the negative. Okay, you can ask me why it has to be negative. Tengok kalau K saya positif. Okay, obviously kalau K saya 0, you won't have solution for this. You akan dapat constant saja kan? Okay, so this will not be an option at this case. But kalau K saya lebih besar daripada kosong, such as K equals to lambda squared kan? Now, K equals to lambda squared. Okay, kalau K saya lebih besar daripada kosong, cuba tengok equation ni. Exponent alpha squared lambda squared T. What can you tell about this equation? Bila time saya, T is the time, right? Bila time saya meningkat, equation ni akan sentiasa, the graph is always going up. Agree with me? So, apa akan berlaku pada heat U? Kita tak boleh control. In another way. Okay? So, we don't want that to be happen. That's why kita akan pilih kita punya K is negative lambda squared. Okay? Negative lambda squared. So that we can have the graph that solution T akan goes to 0. Okay, graph saya kalau dia negatif, graph eksponen negatif macam ni. Kan? Okay, dia akan solution when T approach infinity. Okay, T approach infinity, kita punya solution akan approach 0. That's why we're going to choose K equals to lambda squared. So, my equation 3 ni, saya akan modify dia macam ni You boleh memperkenalkan separation constant ni awal lagi. Okay, exponent. You have negative lambda squared alpha squared T. Okay, this is my equation 3 yang sebenar yang saya nak tengok. Okay tak so far? Tak ada soalan you all? So there are 3 case. Okay, case A, case B, and case C. Kan? Lebih besar kosong, solution saya akan sentiasa. As T approach infinity, solution saya akan sentiasa membesar. Okay, so we're not going to consider that. Bila K kosong, you get a constant instead. Tapi kita nak tengok when K equals to negative in lambda squared. Now, solving the second ODE yang kita dapat tadi kan, the second ODE, solve for equation number 2. Okay, apa dia? This one. X double prime minus KX equals to 0. Now, we already decided to take K equals to negative lambda square. So, saya akan masukkan terus. Negatif-negatif, dia akan jadi positif. Lambda squared X equals to 0 where K equals to negative lambda squared. Okay. Okay, this is second order ODE. Kalau first order, kita boleh guna separable variable ataupun integrating factor. The second ODE, we have to look at, this is homogeneous second order. So we look at the characteristic equation. Ingat tak, characteristic equation dia macam mana? We have, kalau X double prime ni, saya panggil dia M squared. X prime adalah M. X power, X tak ada derivative ni adalah ini power 1, M to the power of 0, bukan? Dia akan sentiasa berkurangan. Okay. So meaning, kita equation ni, characteristic equation dia, okay, we have M squared for X double prime, M squared, plus lambda squared. X ni, kita ada M, which is 0, which is 1, right? So tak adalah. So sama dengan kosong. This is my characteristic equation. Okay, ODE Now, let's look at the solution for this. The characteristic equation dia, M squared equals to negative lambda squared. So, what can you have here? M equals to negative lambda I. Betul tak? You have a complex roots. Saya lupa nak kata tambah tolak Kan you ada tambah tolak bukan kat sini, kat bawah ni. Okay, this is correct. So this is plus minus lambda I. So macam mana saya dapat? You can put negative 1 square root lambda squared, kan? Tambah tolak. So negative 1 is my I. Lambda squared is my lambda. Okay. Now what are the solution for complex root? Siapa ingat? Kalau saya conteng di sini Kalau dia complex root. So note note catatan saya adalah kalau di complex root alpha plus minus beta I kan. So kita punya solution yx equals to exponent alpha x a sin beta x plus b cos beta x. Betul ke? Macam ni? Setuju tak kalau dia complex root? Betul, Syazah? Okay, betul kan? Okay. Sebab in our case, alpha saya tak ada. Alpha saya kosong. Kalau alpha kosong, e to the power of 0 is 1. Okay, tapi jadi solution saya hanya melibatkan beta sahaja. So, I can say because this is an involving function, variable saya ada x. So, saya boleh kata x of small x involving, we have a sin beta. My beta is lambda. Lambda x plus b cos lambda x. Okay. Are you with me so far? Okay. Now, tadi saya ada kata, kenapa nak tulis constant, kenapa nak tulis tambah, whatever you call it, what is it? Tambah C1 tadi kan? Sebab dia melibatkan banyak A. Nampak? A sama. Kat sini pun A. Nanti kalau you buat B dengan, kalau constant ni you buat B dengan C, nanti akan lagi confused. Okay. So, what it mean that, kita mula dengan UXT equals to my big X big T. Okay. A better way to write this, saya skip tadi. Better way to write this adalah X of small x. T ni melibatkan small t. Okay. What is the equation T tadi saya dapat? Saya dapat exponent, A exponent negative lambda squared alpha squared T. Now, big X ni pula saya dapat A sin lambda X plus B cos lambda X. Now, This is why I say constant tadi kita boleh abaikan lah sebab there's no way writing two constant like this. Okay, so the right way to write this is exponent negative lambda squared alpha squared t hanya ada untuk sini saja. A sin lambda x plus b cos lambda x. Okay, so this is my solution pattern. So actually, kalau betul kita punya non-zero boundary condition ni, memang ini yang you akan dapat. Okay, step by step atas tu untuk tunjuk macam mana dapat ni. Okay, now the real question is, what is A and B? That's why you need your boundary and initial condition. Okay, kita akan gunakan initial condition dan boundary condition to solve for A and B. So first use the first boundary condition. Di mana first boundary condition is given as u0t equals to 0. Okay, so what is u0t? Meaning when x is 0. Kan? uxt kan? So when x is 0, okay, kita tengok. When x is 0 kat sini. Bila x saya 0, kat sini sin 0 will be 0. Okay? Cos 0 is 1. So, saya akan dapat exponent negative lambda squared alpha squared t A sin 0 plus B cos 0, which is equals to 0 based on the condition given. Okay, so simplifying this, I have exponent negative lambda squared alpha squared t. Sin 0 is 0. Cos 0 is 1. Okay, so what can you say? So, saya boleh bahagi semua dengan eksponen ni, tinggal B sama dengan 0. B equals to 0. Okay, so that will make you easier. So, now my equation tadi bila B 0, dia akan tinggal sin sahaja. Okay, so let's do that. So, now my uxt will give me exponent negative lambda squared alpha squared t A sin lambda x. Okay, so B dah kosong kan? So yang ni dah kosong. Okay. Now from here, how do you find A? Use the second boundary condition. Second boundary condition dia kata ULT equals to 0. Kan? You kena tahu boundary condition ni dapat dari mana? So I can just go back up here. I can just show you where I am referring to all this boundary condition. If let's say you don't know what I'm doing, this one. This is my first boundary condition. This is my second boundary condition. Okay, this is my initial condition. Initial condition ni bila T saya sama dengan kosong Okay, so kita nak apply second boundary condition now. ULT equals to 0. Okay, let's look at ULT equals to 0. So what happen equation ni bila X sama dengan L. So LT you have exponent negative lambda squared alpha squared T A sin L lambda kan? X saya dah jadi L. Okay. Equals to 0. Equals to 0. Okay, now obviously saya boleh bahagi dengan semua dengan eksponen. So dia akan tinggal A sin L lambda equals to 0. Okay, can I say A equals to 0? Everyone. Can I say that? Shazri, boleh ke saya cakap A sama dengan 0? Shazri, boleh ke?
Ya doktor.
Boleh ke? Boleh. You rasa boleh? Saya cakap A sama dengan 0.
Pasti doktor.
Tak pasti. Siapa yang tahu? Hafiz. Okey, Hafiz kenapa tak boleh? Hafiz, come on. Tell me something. Why you think you cannot have A sama dengan 0? Macam saya yang sangat shock menulis, bercakap kan? Ha. Mana Hafiz? I want to hear your voice, Hafiz. Mic rosak ke Hafiz? Ataupun boleh type ke? But I would like to hear your voice. Kalau you dengar, saya tengok thumbs down tadi kan, you kata tak boleh 0. What do you think? Mungkin Hafiz malu kot nak bercakap. Hafiz, siapa yang tahu kenapa tak boleh 0? Hafizah? Tahu? Fatimah? Hello? Jawapan dia senang je. Tahu ke tak tahu? Okey. Kalau tahu, kenapa? Tahu. Kalau tak tahu, tak tahulah.
Kalau A tu sama dengan kosong, kita tak dapatlah cari lambda tu sama dengan apa.
Okay, thank you Syazah. Syazah said like that. Kalau A sama dengan kosong, kita tak boleh cari apa-apa. Okay, actually kalau look at the solution here, why are we searching for equation tadi kan? Ni, mana? Yang ni. Yang ni, yang lepas B sama dengan kosong, this is what we get. Betul tak? Kalau A kosong, apa akan berlaku pada equation ni? Nothing. UXT equals bila A 0, UXT equals to 0. So you don't have a solution. That's why my A cannot be 0. Cannot be 0. So we cannot let A equals to 0. So kita kena continue, okay? Hoping that A is not 0, saya kena cari. Okay, sin L lambda equals to 0. Now, apa nilai di mana sin boleh bagi saya 0? Okay, sin 0 berlaku di pi, 2 pi, 3 pi. Don't forget, negatif pi pun dia akan bagi, so positif negatif pi lah. Positif negatif 2 pi, positif negatif 3 pi and 4 pi. Semua akan bagi sin 0. So we can say that L lambda equals to n pi plus minus n pi. So what is my lambda? My eigenvalue here, I can say n pi over L. Okay, this is my eigenvalue yang kita dapat. Okay, now good. Kita dah ada eigenvalue, hoping that my A cannot be 0. So now putting the solution, what we will have, UN. Sebab dia dah ada N sekarang. UNXT equals to, tadi kan, yang equation yang saya bintangkan tadi. Ya. Kita ada ni. Okay, equation ni So, nampak je lambda, saya akan tulis sebagai n pi over L. So, kita ada eksponen negatif. Saya tulis macam ni dulu Lambda n, lambda squared kan? Lambda squared T sin A. Oh, kena ada A A akan jadi AN sin lambda n L. Okay, now saya akan letak lambda sebagai n pi over L. So saya ada macam ni. A n eksponen negatif lambda n squared. So dia akan jadi n pi over L squared T sine n pi x over L for n equals to 1, 2, 3, and so on. Okay, so this is the solution that you get from the boundary condition. Okay, now instead of writing this, I can also write it as unxt summation n from 1 to infinity a n exponent negative n pi. Alpha saya pergi mana ya? Ada ke tak alpha tadi? My alpha is missing. Okay, ada alpha squared Tengok kat sini ada alpha squared. So alpha squared t. So I need to have alpha somewhere here. So n pi alpha over L squared t. Dan kita ada sine n pi x over L. Okay, bila tulis summation ni faham lah. N is from 1 to until infinity. Okay, now we are still not done yet because kita ada constant ni. So what you to do here, you have to use your initial condition now. Okay, initial condition in the question, it says that ux0 equals to fx. Okay, ni standard Kalau usually fx tu dia akan bagi something macam x squared ke, senang untuk you solve lah. But in this case, just general form. So what it says here, when t equals to 0. Betul tak? T saya 0. Okay, so kita ada unx 0, t saya 0. Saya akan dapat summation n equals to 1 to infinity an, kalau t saya 0, exponent to the power of 0 is 1. So saya akan dapat sine sahaja. N pi x over L sama dengan fx. Okay, so now what I can say here, this equation here. Fx equals to summation n equals to 1 to infinity an sine n pi x over L. Okay, now how to solve this? What is an? That's my question. What is an? Okay. What do you know about this thing here?
Fourier
What do you know?
series.
This is my Fourier series. Yes, this is actually my half-range Fourier series. Kalau you tengok muka surat berapa dalam chapter 2, I think page 66. If you have my book, open to page 66. This is my sine series expansion. Okay, saya buat satu note di sini. Half range sine series expansion. Okay, is given as macam ni kan dalam buku summation n equals to 1 to infinity bn sine n pi x over p kan? Okay, bila x saya from 0 to p. Ni dalam nota di mana bn saya adalah 2 over p integrate from 0 to p fx sine n pi x over p dx. Cuba kita bandingkan tengok, are they the same? Yes, yang tak sama bn lah. What is my p? P is my L. Okay, this is why you have to learn about the Fourier series first. Kalau kita tak belajar, susah nak solve. Okay, based on this note, I can say that this fx equation and this equation, they are the same thing, except my P is L. AN is my BN. So what is my AN? Kita boleh terus ambil result dia. 2 over P, which is 2 over L, summation from 0 to L, this is my P equals to L, fx sine n pi x over L dx. There you go. There you go. This is my solution for AN. So what is my final solution? Kita nak cari U kan? So the solution for that heat equation is given by UNXT equals to summation n equals to 1 to infinity AN exponent negative alpha n pi over L squared T sine n pi x over L, where AN adalah yang ni. Kena mention AN dengan kena mention UN. Okay? So this is the solution for the heat equation. Kalau fx saya, misalnya fx sangat senang. Fx saya adalah constant. Boleh tak you integrate? Dan L pula, dia dah bagi tahu rod dia, panjang rod ni, this is from 0 to L kan? Kalau panjang rod ni 1, so obviously you boleh integrate from 0 to 1. Okay, fx ni pula, dia dah bagi tahu fx is 10 misalnya. Boleh integrate tak? Boleh. So you can integrate and then masukkan dalam equation UN ni. Panjang panjang solution untuk zero boundary condition. So what do you think? What do you think, everyone? Okay tak? Kalau bagi soalan final assessment, something like this, and then just boundary condition ataupun equation yang berbeza, agaknya boleh solve ke macam ni? You have to follow the step by step lah. Okay, apa step dia? First, use separable variable untuk pisahkan dia kepada x and t, and then find the ODE for the t, find the ODE for the x, gabungkan dia balik. Lepas dah gabungkan, apply boundary condition pertama, boundary condition kedua untuk cari constant A and B, and then baru kita apply initial condition untuk dapatkan constant yang lagi satu. Now, your solution will always melibatkan half range ni. Boleh guna terus. Boleh guna terus. Okay? You always, sebab dia adalah interval dia finite interval. You can use that. Okay, you boleh tengok example 3.1 dalam buku yang menyatakan kalau solution dia berbeza. Macam dia ada kata, what is the length of the bar and what happened. So you can do that. Okay, any question everyone? Tak ada nak tanya ke? Semua jelas ke step by step yang saya tunjuk ni? Sebab first time tak ada yang minta stop, tak ada yang berhentikan saya untuk tanya soalan. Okay. So the next part is about the non-zero boundary condition. Tapi non-zero pun dia biasanya kalau you dah dapat great information, good information about the zero boundary condition, non-zero ni lebih kurang sama. Okay, cuma konsep dia adalah you can watch my video Saya tak nak terangkan berkenaan dengan non-zero boundary condition. But konsep dia adalah kita akan tukar non-zero kepada zero boundary condition. Baru you akan solve balik menggunakan separable variable. So the good example is on page 130 and 131. Ada juga pada video yang saya dah share. Konsep dia sama. Okay, you can also look at example 3.2. Now, maybe we can take few minute break. Saya bagi break dalam 5 minit ke. Saya nak tunjuk lagi satu kalau kita ada infinite interval. Boleh tak? Kalau infinite interval macam mana kita nak solve? That's one example that I would like to share. Okay, so now 343, kita akan continue. 348. Nak 5 minit ke nak 2 minit? Okay, so maybe just go rest, go do some stretch. Duduk lama-lama pun sakit belakang kan. So, I mean, I don't know about you, but I always get my back pain. So, do some stretch. And then I'll see you at 348 eh. Okay, saya nak stretch jugalah. Okay, everyone. Can we start now? Semua ada ke? Sekejap, saya tengok. Partisipan 20. Okay, semua ada So, boleh tak kita mulakan sekarang? Few more minutes. Give me like about 15 minutes. Okay, so before that, let me just tell you about your homework. Nanti saya lupa, okay? Your homework. Please, everyone, please do the homework. Okay, your homework is, saya nak you solve for, there's 2 questions. Number 1, this is your problem. Ut equals to alpha squared uxx. I'm going to give you this boundary condition for you to find the solution. Partial u over partial x lt equals to 0. Masih lagi finite interval. This is for t greater than 0. And then initial condition here ux0 equals to fx. Okay, so I'll just give you a hint. So what this means here, heat transfer in a bar or rod with length L, and there is, if you look at 0 kan, look at 0, there is no heat loss, tapi both rod ni, kalau tengok equation ni, apa yang kita tahu? Yang ada derivatif ni. Tadi saya dah terangkan. Apa yang you faham? Tengok equation saja. Okay. This is what it means. Saya nak semua tengok. So, maksud dia adalah kita ada satu rod ni, panjang dia L. Okay, panjang dia L. Tak ada heat loss sebab dia constant kan? Kosong-kosong. Tapi derivatif ni bermaksud ada penebat. Both end ada penebat. Insulated endpoint. Dua-dua endpoint ni ada penebat because of this derivative here. Okay, that's the difference. Okay, cara dia sama. Cara macam you solve separable variable. Nanti masa nak ambil boundary condition pertama, this is the first boundary condition, this is the second boundary condition, you kena ambil, you kena differentiate dulu respect to x, baru you boleh buat. Okay, I want to look at how you do it. By next week, mungkin you dah upload dah soalan. So you have one question with insulated rod. And then the other one, something like this. Ut equals to alpha squared uxx. Partial u over partial x 0 t equals to 0. And then this one. ULT equals to 100. And then ux0 equals to fx. Okay. So what this tells you, okay, ni tadi Newman boundary condition kan? Newman boundary condition. Now what this equation tells me, now the rod is, the interval dia masih from 0 to L. Okay, so let's look at what happened here. So kita ada rod, panjang dia adalah L. Okay, that is good. Sebab kita ada mix boundary condition. Mix. Satu ada derivatif, satu tak ada derivatif. Tapi satu held constant at 100. Okay, satu. So kat sini lah. Obviously pada L kan. Pada sini dia held constant at 100 dan pada sini ada penebat. Itu maksudnya. Okay, left end is insulated. The right end is held at a constant 100. Itu maksud dia. Okay. So exactly same like how you will solve for the problem just now. Cuma yang berbeza nanti masa kita nak apply initial condition. So I would like to see your solution. What do you get? Boleh Okay, now like any question berkenaan dengan homework week 10? Faham tak soalan? Ada apa-apa nak tanya? Okay, tak ada. Kita akan balik kepada one last problem here. Okay, when you have infinite intervals. Okay, saya dah kata dah. If you have infinite interval, you're gonna use Fourier transform. Fourier transform. Okay, so let's look at this. Saya nak bagi contoh yang senang untuk kita solve. Let's look at this problem here. Partial u over partial t squared equals to negative c squared partial squared u over partial x4. Now, x is from minus infinity to infinity. The initial condition is given as ux0 equals to fx. And then kita ada another initial condition, ut derivative x0 equals to gx. Okay. Now, how I know I need to use Fourier transform? Sebab kita ada infinite interval. Now, I hope you have watched my Fourier transform video. Introduction tu lah. Kalau tak tengok, tak boleh nak buat. So, in the book, akhir ujung sekali, page 210 onwards, kita ada table Fourier transform. Okay, yang saya akan menggunakan adalah this one. Okay, kalau f something like this, kita panggil dia Fourier transform of the nth derivative. Fourier transform of the nth derivative. So notation dia macam ni, kalau dia f of n, kita akan gunakan equation ni I omega n f hat omega. Okay, so this is the one we're going to use for nth derivative. Now look at to your problem. Sama macam konsep Laplace transform yang you belajar untuk ODE. To apply the Fourier transform, you need to apply Fourier transform to the right side and the left side. So saya akan ambil Fourier transform. Take the Fourier transform of partial squared u over partial t squared. Sama dengan negative c squared ni constant. So take the Fourier transform of partial squared u over partial x4. Okay, stop me kalau you rasa macam susah. Okay, what is this partial squared u over partial t squared? In a small notation, saya boleh tulis dia macam ni. UTT equals to negative c squared Fourier transform of u x x x x. 4 kan derivatif dia. Okay. Now, kita akan ambil Fourier transform for this one based on this nota yang ni, table yang pada buku belakang. So, it said that n ni, the nth is my derivative. Okay, n ni adalah derivative. So, ni adalah second derivative, betul tak? So, kita ada, but we are not taking. Okay, we are taking the derivative with respect to x, not respect to t. Okay, sebab kalau tengok Fourier transform page berapa ya? Page 210. Okay, in your book, page 210. Table tu selalu mula dengan fx. So, kita ambil terhadap x. So, this one, I can just write it as t squared over dt squared u hat omega t. Dia akan dapat macam ni. Okay, Fourier transform ni, kalau kita buang f ni, the curly bracket f here, you will get this notation. Now, for this term here, negative c squared, baru kita akan tengok table ni. So, I omega I omega N saya berapa? 4. N equals to 4. So 4 F hat. Kalau function saya F, dia akan jadi F hat. Kalau function saya U hat omega T. Are you with me so far? Thumbs up kalau semua boleh. Okay, good. Ada yang tangan dah angkat, bagus. Okay, now simplify. So this is continue, d squared over dt squared d, d t squared, bukan partial. U hat omega t, okay, I to the power 4. I squared is 1, right? So I2 to, it will be just 1. So we have negative c squared omega 4. Omega power 4, U hat omega T. Okay, now what is this? Ni equation yang kita dapat. Okay, so what we see here, okay, yang ini, kalau saya nak simplify dia, this is actually my second order ODE. Siapa agaknya nampak dia macam second order? Okay, saya tulis balik d squared over dt squared U hat omega t plus c squared ni bawa ke sebelah kiri omega 4 U hat omega t. Okay, kalau misalnya U hat ni adalah Y, kan? Kita akan dapat partial D. Kita akan dapat apa? Kita akan dapat Y double prime plus C squared omega 4Y. Setuju tak? Setuju tak? Sebab dia derivative. Second derivative here for the U and no derivative here. So this is my second order ODE. Second order ODE. Sama macam konsep tadi, we need to find the characteristic equation. So the characteristic equation is m squared plus c squared omega 4 equals to 0. So m squared is plus minus negatif. Ada negatif kan? Bawa pergi ke sebelah sini ada negatif c squared omega 4. So negatif. Nak tulis plus minus dulu. Negatif c squared omega 4. Now ambil square root. M equals to negatif akan jadi I c omega squared plus minus. Okay, so we have a complex root. You have a complex root where your solution for complex root, ingat kita bukan solve for y, kita solve for u hat. So u hat omega t equals to complex root saya adalah a omega constant, a omega sin. Sin ke cos ke? Cos. Beta. Beta saya adalah c omega squared t plus b omega sin c omega squared t. Okay, I hope you are with me. Dia sebenarnya okay, so dia sebenarnya A cos B sin, betul tak? Cuma saya nak tulis bracket dalam bentuk omega ni supaya kita tahu. A omega ni bermaksud A omega dengan B omega is a constant. Constant in T. Okay, tapi saya nak tulis omega lah. So kalau it's actually something like this. A cos ataupun sin C omega squared T plus B sin C omega squared T. Okay, they are the same thing. Okay, so this is a complex root yang kita dapat. Now, what you do here, okay, so far okay, now kita akan apply initial condition, okay. Tapi initial condition dia adalah Ux0 equals to Fx. Boleh tak kita apply terus kepada condition ni? Tak boleh sebab this is U hat. So you need to use Fourier transform. Okay, take the Fourier transform for the initial condition. take the Fourier transform for the both side fx. Okay, sama macam your Laplace transform lah konsep dia, okay? Bila saya ambil Fourier transform untuk u ni, dia akan jadi u hat. U hat x akan jadi omega 0. Okay, the idea of Fourier transform ni, x akan jadi omega, nanti kita akan ambil inverse Fourier transform untuk jadikan dia balik x. Okay, and then this one akan jadi f hat omega. Okay, now kita boleh apply pada kita punya solution. Okay, kita boleh apply. So what happen when t equals to 0? When t equals to 0, kita ada u hat omega 0. Okay, A cos t saya 0 plus B sin t saya 0 sama dengan f hat omega. Ya, condition saya bila t saya 0. Okay, sin 0 is 0, cos 0 is 1. So what is A? My A with respect to omega is f hat omega. That's the first condition yang kita dapat. Similarly, for the second boundary condition yang dia bagi. What's my second boundary condition? Saya nak cuba tengok. Saya dah lupa. Ni. ut x0 equals to gx. Okay, that's my second. And condition t is 0. So I have u t x 0 sama dengan gx. Similarly, we need to apply Fourier transform for this initial condition here. Fourier transform of u t x 0 equals to Fourier transform of gx. Okay, now ut ni dia akan kita tak apply Fourier transform with respect to t kan, we only apply to x. So this will be d over dt u hat omega t. Omega t saya 0 lah. Okay, so buat 0 sama dengan g respect to x will be g hat omega. Okay, now kita nak apply kepada equation saya yang mana? Yang ni. This one. This equation ya. Di mana kita tahu B saya dah 0. So tinggal ni lah. U hat omega t equals to A saya adalah F kan. Tapi kita buat dulu. Kita jangan ubah dulu. Tulis dulu. U hat omega t equals to A cos C omega squared T plus B sin C squared T. Okay, kita buat dulu sebab kita tak kata B saya 0. Kita tak lagi B. A yang kita cari. So you have, saya nak salin dulu. U hat omega t equals to A omega cos C omega squared T plus B omega sin C omega squared T kan? Okay, saya kena ambil, this is U, take the derivative U hat respect to T. So saya nak ambil D over dt. U hat omega t. Maksudnya saya nak ambil derivative respect to time. What do you get? Respect to time. Okay, A ni constant tapi differentiate cos will give me negative sin. Negative sin C omega squared T. Differentiate dalam ni respect to T. C omega squared. So saya ada negative C. Jangan lupa A Saya nak tulis dulu, lepas tu you bagi tahu saya betul ke tidak apa yang saya buat ni. So kita akan dapat negative AC omega squared sin. Betul tak? Kalau kita differentiate ni. Respect to T. Thumbs up if you agree with me. Okay. Differentiate cos give you sin. Negative sin. Differentiate bracket ni. Kan dalam ni respect to t dapat c omega squared. C omega squared. A tu constant lah. Okay, harap boleh Now similarly differentiating this, saya akan dapat c omega squared b cos c omega squared t. Differentiate sign will give me cos, and then differentiate inside the bracket here will give me c omega squared like this. So saya nak tulis dia dengan baik. U hat t omega t now. We have negative a omega sine c omega squared t plus b omega c omega squared cos c omega squared t. Okay. Kita dah differentiate equation ni. Now baru kita nak apply condition kita. Baru boleh apply sebab dia dua-dua dalam bentuk derivative. So what happened when t equals to 0? When t equals to 0, what happened? So kita nak tengok equation dia jadi apa So when t equals to 0, kita ada ut omega 0. Okay, apa berlaku? Sama juga kan? Sin bila t 0, yang ni kosong. Yang ni dapat 1. So kita akan dapat c omega squared b omega ataupun b omega cos 0 is 1. When t 0, this is 1. This is equals to g hat. Condition saya kata g hat kan? Okay, g hat omega. There you go. Boleh tak saya cari b? Boleh. What is b? B omega equals to g hat omega over c omega squared. Okay, kita dah ada A, kita dah ada B. So, masukkan dalam equation saya yang sebenar tadi. This is the original kan? Ni yang original. Where's my original? This one. This is my original equation. So, my solution is, saya dah dapat A omega dengan B omega kan? So, U hat omega T equals to A omega tadi, F. F hat omega cos C omega squared T dan B omega adalah ni. Plus G hat omega over C omega squared sin C omega squared T. Okay, so this is not the solution, but this is almost the solution. Okay, ingat kita buat Fourier transform tukar kepada omega dan T. Kalau kita ambil inverse Fourier transform, semua ni U hat omega T akan jadi UXT. Okay, dan inverse ni definasi kalau you tengok Fourier transform definition dalam video saya ke apa ke, to take the inverse, okay, saya kena tulis kot just to remind you. Okay, let me just show you. Whiteboard saya dah penat. It's on page 76 in your book. Oops, there you go. Page 76. Okay, so apa page 76 in the notes? Okay, dia kata to take the Fourier fx, dapatkan balik dalam bentuk x adalah 1 over 2 pi from minus infinity to infinity f hat omega e I omega x d omega. So untuk dapat balik uxt, kita kena apply 1 over 2 pi minus infinity to infinity. Kita bukan f omega dah. Kita punya adalah u hat omega. Semua ni. Okay. F hat omega cos c omega squared t plus g hat omega over c omega squared sin c omega squared t, and don't forget exponent I omega x d omega. Okay, do not solve this integral. Jangan solve. Sebab kita tak tahu ada f hat, kita tak tahu apa dia g hat. Don't solve. Okay, just leave your solution like this. Okay, this is how you use Fourier transform to solve your integral. Okay, dia akan senang kalau kita punya initial condition yang dia beri fx dengan gx tu adalah constant. Kalau constant, you boleh guna improper integral to integrate. But in this case, just leave your question like this. Okay, that's all. That's all saya nak terangkan hari ini. Any question everyone? Hari ini kelas sangat diam. Saya tak tahulah kenapa. Sama ada dia dua je. Sama ada you faham ke ataupun sama ada you mengantuk. Okay, class, anything you want to say for today's class? That's all I have. That's all I want to share. So, minggu depan saya nak tengok hyperbolic and then elliptic. Okay, dalam final assessment nanti dia boleh ada sama ada hyperbolic, parabolic ataupun parabolic elliptic ataupun parabolic hyperbolic. Salah satu problem lah. Okay, saya takkan tanya dah Fourier series sebab Fourier series hanya melibatkan solution yang melibatkan heat macam ni Okay, class? What do you anybody nak want to say anything? Syazah nak cakap apa ke?
Tak ada.
So boleh ikut ke hari ni? Kelas?
Boleh, Doktor.
Boleh. Hafizah? Saiditana? Saidatina. Saiditana pula. Saidatina. Boleh Saidatina? Saidatana. Tina. Dah pening dah. Okay. Boleh?
Kena tengok.
Ya, Akila kata agak berat. Memang agak berat. Kalau you tengok cara saya ajar pun macam cepat kan. You kena tengok lagi sebab itu sebab konsep Fourier transform tu saya bagi dalam bentuk video supaya you boleh tengok dia balik. Okay. PDE ni susah bila integration dengan differentiation you susah. Okay, and lagi satu, sebab dia ikut step by step je. Kalau ikut je step by step penyelesaian saya, you sepatutnya boleh buat. Okay, cuma masalahnya kalau saya alter sikit soalan, you kena fikirlah. That is like higher order thinking skill kat situ kan. You kena fikir, okay. But kalau macam ni lah step dia, that's how you do it. Okay, so if you have problem in terms of how do I get that solution, you boleh tanya saya boleh tunjukkan lah. Okay, so konsep tu kena ni Okay class, that's all for today for me. So, kita akan tengok minggu depan untuk hyperbolic ke, okay? So, let me know kalau ada bab dalam buku yang kita belajar yang you tak faham, yang perlukan lagi banyak explanation Let me know. Okay, so if no question, I will see you next Friday. And don't forget, I would really want to see your solution for mana tadi homework week 9. Mana? Yang ni. 2 soalan ni. Okay, saya nak tengok jalan pengiraan untuk 2 soalan ni. So, I hope you can submit to me before the class start. Okay, class. See you next week. That's all from me for today. Bye for now.
Doktor.
Thank you, Doktor.
Welcome.
Doktor.
Welcome.
Doktor.
Okay.
Thank you, Doktor.
Okay.